now we're ready for part 4 of the lab, which is entitled Rotational Energy. And so for this simulation, you are going to go up here to O Physics, Rotations, and then down to here where it says Rotation, Rolling, Motion. So click on that and you should be able to see this thing right here. Now it's kind of complicated because it's showing the rotational and kinetic energies of different kinds of objects, which we don't care about. So I'm going to click off this one and then click off, we don't want the cylinder, and we don't want another cylinder, and we don't want this one. So we're just going to click off all of those things, and now we're only dealing with the bowling ball. And so that is a solid sphere, so the bowling ball. And you can see over here that you have its parameters, its mass, its radius, different things that you can change about the simulation. Okay, so now let's go to the lab here. And we want to learn, what do we mean by kinetic energy? So we said that things had potential energy, energy of position, and then they had kinetic energy, which was energy of motion. And so when something is moving sideways, it has energy, it has kinetic energy, and then we could put a T on this for translational. So this is the kinetic energy it's going to have when it's moving sideways or up and down. So when it's moving in a straight line, it's going to have this kind of energy, and it's going to be given by 1/2 mv squared, where m is the mass of the object, v is its linear speed. So I wonder if we could do this for something that is rotating. And yes, we can. So this is going to be a type of energy. It's going to be kinetic, but it's going to be rotational. So it's going around and around. Okay, now it's still got the 1/2, but instead of the m, we're going to use I. So remember, when we talk about things that are rotating, we use the moment of inertia I instead of m. And instead of v, we're going to use omega, because that is the rotational speed. And then we still have to square it. Now, first question, 15. Why are the initial translational and rotational kinetic energies 0? So if we go back to the simulation, there's the ball. So why doesn't it have any kinetic energy? So both of those are zeros. Well, look at what the ball's doing, and then also look at what it depends on. So answer that question. Then, what kind of energy does the ball, the bowling ball, have before it was released? Okay, it was just like when we did the lab, where you had something in your hand, and so just before you release it, what kind of energy does it have? And then that energy is being turned into when it hits the ground. Yeah. So go ahead and put that in there. Okay, now we're going to click on Run. So we're going to go back to the simulation, click on Run, and look at what happens to this number, and then this number, and then this number. And remember, you can pause it at any time so that you can see better what's happening to those numbers as it goes down. Okay, so there's your various numbers, and you should notice what they're doing. So what's happening to the linear velocity? What is happening to the linear and rotational kinetic energies? So what's happening to V, what's happening to this, and what's happening to that? So go ahead and put that in there. So all I wanted you to see was that the kinetic energy depends on speed. So if the speed's increasing, so is the kinetic energy. So that's part 4, and now we'll take a break, and when we come back we'll do part 5.